We often think of history as something written in books, told through old stories, or found in ancient ruins. But what if the biggest story was written inside us, in our bodies? Today, science lets us read the past in a whole new way by studying our DNA. This tiny code inside every cell carries the secrets of who we are, where we come from, and what we've survived. But when scientists look closely at the Y chromosome, the piece of DNA passed down from father to son, they found something shocking. About 5,000 to 7,000 years ago, something strange happened. Almost all male genetic lines vanished. To put it simply, 95 out of every 100 male family trees suddenly ended. It wasn't a volcano, it wasn't a virus, and it wasn't the kind of war we usually imagine. This silent collapse happened across huge parts of the world, yet we're only just beginning to understand it. What caused this mysterious wipeout of nearly all men? And how did just a few survive to become the ancestors of almost every man alive today? Let's uncover the story hiding in our genes. DNA never forgets. To understand this mystery, we first need to know a little about DNA. Every human being carries two types of special DNA lines, one from our mothers and one from our fathers. Mitochondrial DNA comes from mothers and is passed down to all their children. But the Y chromosome only comes from fathers and is passed down to sons. So if we follow mitochondrial DNA, we see the mother's side of the family tree. If we follow the Y chromosome, we see the father's line. When scientists began studying ancient DNA from people all over the world, they found something odd. The female DNA line looked normal, but the male line, shown by the Y chromosome, had a huge gap. Across Europe, Asia, and the Middle East, there was a massive drop in Y chromosome diversity about 5,000 years ago. That means almost all the male lines vanished. Only a very small number of men passed their Y chromosomes to the next generation. Scientists call this a genetic bottleneck. This wasn't just one small region. It happened across continents. The women's lines kept going, but something stopped most of the men's line. Whatever it was, it must have been massive and deadly for male bloodlines. The first clues: mass graves. To figure out what happened, scientists looked for clues in the ground. Archaeologists started digging into ancient burial sites, and what they found was disturbing. In places like Talheim, Schletz, and Herxheim in Germany and Austria, they uncovered mass graves. These weren't normal cemeteries. These were pits filled with dozens and sometimes hundreds of bodies. Many of them were men. Their bones showed signs of violent death: crushed skulls, broken legs, and even sharp weapon cuts. Some were clearly attacked while trying to run away. But the women were often missing. Where did they go? Some experts believe the women may have been taken by the attackers, maybe forced into new clans or families. In one site, there was even evidence of cannibalism, bones broken open to suck out the marrow. It was brutal, dark, and terrifying. These weren't just random killing. These looked like full-blown clan wipeout. Entire groups of men were erased in a single event, and this pattern wasn't seen in just one place. Similar graves have been found in different regions. It was a sign that something much bigger was going on. Extreme clan war. So what could cause such a massive wipeout of male bloodlines? One theory is what scientists call extreme clan war. Back then, about 5,000 to 7,000 years ago, people lived in small groups called clans. These clans were usually patrilineal. That means the men passed down their name, their land, their tools, and their power to their son. But in this kind of system, if one clan lost a fight, it wasn't just about losing land. The winning clan would often kill every man in the losing group to erase them completely. Then they would take the women and raise new children from their own male line. It sounds harsh, but in those times, survival and power were everything. These wars weren't like giant battles we read about in books. They were small, deadly attacks. Clan against clan, village against village. But they happened again and again for hundreds of years. Over time, these repeated attacks may have erased most male genetic line. Only the winning clan's men had children. The rest were gone forever. It didn't take a world war to change history. Just small, constant violence passed down through generations. Social structure killed genetic lines. But what if it wasn't just war? What if society itself helped erase these male lines? Another idea is that the structure of ancient communities played a big role. Back then, the most powerful men often had many wives or partners. This means one man could have lots of children, while many other men had none. Even if those other men stayed alive, their bloodlines ended because they never became fathers. We can see this happen in the animal world. In a group of lions, only the dominant male mates with all the females. The same is true for gorillas. The strongest one gets to pass on his genes. The rest just watch. Humans may have done something similar. Imagine a village where only one leader had 20 children, and all the other men had 0. After just a few generations, almost everyone would be descended from that one man. The others would vanish from the family tree, even if they were still alive for many years. We've seen something like this in history. Genghis Khan, the famous Mongol ruler, lived around 800 years ago. Today, scientists think over 16 million men carry his Y chromosome. That's because he had many children, and his sons had many children. His line exploded while many others faded. This could explain part of the mystery. A system where only a few men got to reproduce would naturally cause a drop in Y chromosome diversity, even without violence. Other theories and why they don't fit. Scientists have also come up with other ideas. Some believe that a deadly disease may have affected only male fertility. Maybe something in the environment made it harder for men to father children. Or maybe fewer boys were born during colder periods in history. Some studies show that nature sometimes produces more girls in tough conditions. Others say maybe there were plagues or famines that hurt men more than women. But here's the problem. None of these theories fit perfectly. The Y chromosome collapse happened across many places and over a long time. And if it were just disease or nature, we'd expect the same to show in female DNA too. But the women's line stayed strong. Also, many types of suffering don't leave marks on bone. A man who never became a father leaves no scar in the skeleton. But in DNA, his story ends. So much of what happened is invisible to our eyes, but not to our genes. This is why war and culture are still the strongest theory. They can explain why men were wiped out across huge regions slowly, clan by clan. Even if there were no signs of fighting in every place, the system itself may have made sure only a few men had a future. It's hard to believe, but it's true. Around 5,000 years ago, something caused 95% of all male lines to vanish. Not just in one country, but across continent. It wasn't a single battle. It wasn't a disease that we can prove. It was something deeper, something built into how ancient people lived and fought and passed on power. Whether through war, social rules, or a mix of both, most men back then never got to be ancestors. Their names, their bloodlines, their futures erased. But something changed after that. As societies grew, people started mixing more. Trade connected faraway places. Walls between clans began to fall. Slowly, male genetic diversity came back. New family trees grew again. And today, every man alive carries the Y chromosome of one of those lucky survivors. Their story lives in our cells. It reminds us that history is not always peaceful, that the quietest events can have the biggest effect, and that sometimes what we forget tells us more than what we remember. So the next time you look in the mirror, remember, you carry a secret from a battle you never saw, a battle that shaped the future of humankind. Thanks for watching. If you like this video, give it a thumbs up and hit subscribe so you don't miss what's coming next.
idea that tries to answer how the Y chromosome in particular was so obliterated beyond just the violence, states that as the revolution was underway, societal structures reorganized, with more and more people forming patrilineal kin groups. Perhaps because trust was a rare commodity and it was easier to rely on those you were related to. And this resulted in unrestricted movement for women, but very much restricted for men. In other words, no outsiders allowed if you were a guy. This would have made the Y chromosome very vulnerable, and explains why it was so affected when these clans waged war against one another, and ultimately leading to the genetic bottleneck being very much one-sided. But like many ideas, there are those that disagree with this hypothesis, and instead actually propose a peaceful explanation to this. Now obviously, as the abundance of skeletons show, violence was quite prevalent at the time. But, in terms of the genetic bottleneck, one team of scientists thinks that patrilineal clans may have split up often through a peaceful process called lineal fission. Since these new clans were made up of closely related males, their Y chromosome lineages became more vulnerable to disappearing over time, especially due to environmental hardships. This led to a gradual drop in Y chromosome diversity, as some male lineages were very successful in surviving and others slowly faded away. This was only further compounded by reproductive fitness, where some groups were much more successful, which led to more growing and splitting, only reinforcing their dominance, while others just couldn't keep up and eventually vanished. Of course, there is then the possibility that actually both of these ideas were on the right track, with peaceful and violent factors having worked together to bring the effective male population way down. Whatever the case, there's certainly no denying that something happened, and to this day, the legacy of this bottleneck remains, with certain populations still not being at the same diversity as pre-bottleneck levels. And if this had never happened, it's fair to say that things would be quite different. Still, our genetics overall have mostly recovered, and we don't kill everyone else on sight, so at least there's that improvement. Though it does lead to a second question, which is, how did all this potential bloodshed end? Well, it didn't, at least not in an absolute sense, because over time, from a pure numbers point, more people did end up dying in wars, especially thanks to new technology. It just so happens that we grew faster than we died, so things got relatively better. Then sometime later, as more complex societies were created and trade and diplomacy arose, things cooled off. However, when you look at the last 600 years, you can see that this cooling off was only very recently, as it was only in the last 100 or so that we really started to turn a new leaf, with the amount of conflicts starting each year being on a mostly downward spiral since World War II. And while it may be hard to believe these days, we do live in an extremely peaceful world compared to the one that used to be. And this is of course reflected in our very long lifespans, which is over 3 times that of the Neolithic ones. And while we certainly do have our very own problems, I for one am glad I don't have to worry about skull cults and shin takers anymore, at least for the most part. Thanks for watching, and until next time, Honest Thing Sue.